Hi, let's talk about TF-IDF, term frequency inverse document frequency in NLP. How TF-ID works, Python implementation of TF-ID in NLP. Let's take first what is TF-IDF. As you can see in this diagram, it is a numerical statistic that reflects the importance of a word in a document. It is commonly used in NLP to represent the relevance of a term to a document or a corpus of document. The TF-IDF algorithm takes into account two main factors: the frequency of a word in a document, that is called TF, and the frequency of the word across all documents in the corpus, that is called IDF. So, taking parameters in these two terms, I'm going to focus these terms as well. Here you can see we have first one is these terms. Below are terms you need to understand. First is the term T. We will be using the terms in the formula. D as the document set of words. N is the count of corpus, total corpus do we have, and corpus is the total document set. What kind of total documents do we have? Here you can see several definitions are also involved. So what kind of definitions are there? First one is the term frequency, which is a measure how often a word appears in a document. A higher frequency suggests greater importance. For example, we have India in a news article, which means India word is very essential for this term. So we can say once this India term is going to focus, going to emphasize anywhere, means we have very important term in this text. Then a term appears frequency in the document, it is likely to relevant to document's content. Next, limitation of TF alone. TF does not account for the global importance. This is for single text document only, not for entire corpus or set of documents. So common words like or, the, may have high TF scores but are not meaningful in distinguished documents. So we can have complete understanding of this punctuation words as well. IDF, it reduces the weight of common word across multiple documents while increasing the weight of rare words. Here is the given formula to calculate TF, and here is the formula to calculate IDF. So you can note down these formulas so that you can calculate this TF-IDF using this certain functions. But I'm not going to calculate this formula because Python is gonna use this formula automatically. Let's take an example using the numerical part. So what is the numerical part here? So I'm going to create this numerical part. This is here I'm going to show the numerical part here. Imagine the term T appears 20 times in a document. Okay, so that contains a total of 100 words. So term frequency would be 20 divided by 200, which is 0.2. Assume a collection of related documents contain 10,000 documents and 100 documents out of 10,000 documents contains T. So this would be log 10,000 upon 100. So term frequency would be TF-IDF would be 0.2 multiplied by 2, which is 0.4. So means we can have the relevant TF-IDF for my relevant documents. Okay, let's see what is the Python implementation of this entire scenario, how code is going to calculate this one. First and foremost, I'm going to import these basic libraries for feature extraction, for TF-ID vectorization, and other terms are also involved. Okay, now I'm going to create a data which is consisting all my text within the given string, and all the sentences are given here. 1, 2, 3, 4, 5, 6 sentences are there. I'm going to pre-process these 6 sentences using TF-IDF vector and object is going to create here. So as far as this object is created, we have just created this object. Now I'm going to deploy this object over my given data. So this would be TF-IDF.vector.fit. Let's initialize this data again. Now we had deployed this data value. Now I'm going to create this bag of word. This would be bag of word, and this would be deployed, converted. First I'm going to convert it this array, and then column will be converted into feature extracted name. Let's create this bag of word, and here I'm going to create this bag of word. Can you see? This is gonna create everything. Now look at this part here. Once we have defined everything, which is TF-IDF, which is first converting into array. So I'm going to convert into array first. Then the column is being created using TF-IDF and converting the get feature name, which is the numerical part, and also giving the numerical value. Now using this TF-IDF, I'm going to convert every word into the numerical value. This numerical value is different from BOG, bag of words, which we have seen in a previous section. So bag of words, if you recall, this was the complete integer value, whereas in this section we had everything in a fraction. Why fraction? Because this is kind of t upon m and multiplied by m upon n. So this entire formula is giving this output. So leveraging out of the box functionality of TF-IDF, we are obtaining this term. Again, what we have done here, we have converted every word into numerical value, but on the basis of their importance. Whereas inside the bag of words, we are just converting into integer format, but inside the bag of words, we are converting into numerical as well as the importance of each word respectively. This was the entire scenario of everything. Let's see in a next section. Thank you.